What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 40, the last question of the third grade math questions that North Carolina released this past school year. We're being asked which answer choice shows two correct ways to arrange 21 pennies in equal rows. Our answer choices have 2 rows of 1, 1 row of 2, 7 rows of 3, 3 rows of 7, and so on. It looks like they're all symmetrical, which that's nice. We don't have to test two different multiplications for each one if we know that we can flip numbers around in multiplying. But, of course, the biggest thing you need to know to succeed in a question like this is multiplication, and this deals specifically with something called an array. So I'll use choice A as an example. If I make, I'll use brown for this because they're pennies. So if I have 2 rows of 1 penny or 1 row of 2 pennies, both of these will actually give me the same answer, and that's 2 pennies. So an array is essentially, I arrange a whole bunch of stuff so that it looks like a rectangle, and then I can just count them up from there by skip counting or whatever. This leads into multiplication, so I'm going to use multiplication to figure out the right answer and then draw the array out in order to show that it actually is correct. So choice A, 2 rows of 1 or 1 row of 2, those gave us 2 pennies, and we were looking for 21, so it can't be A. Choice B, 7 rows of 3 or 3 rows of 7. You could write this as 7 times 3 or 3 times 7. But either way, either of those two expressions will give us the same answer, which is 21. 21 was what we're looking for, so I know that the answer is B. Now, just to go over this idea of an array, I'm going to go ahead and draw out all those pennies. In fact, I'll just use tiny circles right now. If I want to make 7 rows of 3, that's 1, 2, 3, 3 rows, 4 rows, 5 rows, 6 rows, 7 rows. And if I want to count the rows, I can count by threes. And I can say that this is 3, 6, 9, 12, 15, 18, 21. So that's good. I drew it right, and that's the number I'm looking for. And then to do it the other way, my brown marker is getting a lot of use for this question. If I want to do it the other way and do 3 rows of 7, that's 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7. So there's my 3 rows of 7, and I can use a similar idea. I can just skip count by 7s and say, okay, this is 7, 14, 21. The point is, no matter which array I use, it's going to be able to be represented by one of these multiplication expressions. Both of these multiplication things are going to equal 21 when I try to figure them out. So this is just a multiplication question, but it builds on a very specific idea of arrays that comes up a lot in Common Core when multiplication is first being introduced.